So what we show here is a motorcycle part, a rocker arm, which is part of the rear suspension. So it links the suspension system with the spring of the rear boat, and it's a highly loaded part. So it's really structural component with a lot of loads, and we're replacing aluminum milled part with a composite part. That means there's unidirectional fibers with peak polymer around it, and we use our additive fusion technology for this. So it's a two-step process where we combine 3D printing, placing fibers and pure polymer, and then compression molding to consolidate it and also add some complexity to the component, like bringing in the cavity, bringing in the slightly angle, and also put some inserts inside.
So this is very innovative, but the advantage, for example, with other process, it can be made in injection molding, for example, or it's a fusion between 3D printing and fusion, you say, or compression?
It's compression molding, yes, exactly. You could also combine it with injection molding. So for instance, printing a reinforcement element and then overmolding. But in this case, we use compression molding. And the advantage is there is no automated way how to place unidirectional fibers on such a small component. Okay. And with this, we can really replace highly loaded metal parts and also be cost competitive because the process is highly automated. And with this, we can also save the cost. And of course, at the end, it's also about reducing the weight of the part. So in this case here, for this rocker arm, we have only 50% of the weight of the original aluminum version.
Okay, where we can find this part in this motorcycle?
Actually, it's assembled in another motorcycle, but it's down here, part of the suspension of the rear wheel.
And security of this part? The security of this part?
It has the same mechanical performance than the aluminum part.
Okay, and lighter.
And it's much lighter, 50% lighter, same performance, and even cheaper in this case, because the original part is milled from a block. You have, of course, a lot of waste material. It's also not a very cheap process, and with this we can be cheaper than the aluminum version and lighter, which is of course quite a benefit.
Which other kind of applications we can find in other industries?
Yeah. I mean, this is typically mobility application, but we're also strong in aerospace. We have a lot of brackets, hinges we can replace that are nowadays made from aluminum and replace them with lighter CFRP materials. And of course, lightweight in aerospace is a huge topic, especially for the future where we looking for less and less emissions. And this is key factor for that.
Do you think that we can find an opportunity in this kind of parts and process in our country, Mexico City? Or not
for
city,
sure,
Mexico
for sure.
Country.
The whole country, for sure. There are of course, I guess, companies in automotive, aerospace, and some other new mobility concepts where this could be quite a fit. Yeah.
Tell me something about the investment that if you compare with mold machines, other molding machines like injection molding.
Yeah.
So
it's much cheaper. That's a nice thing compared to other big injection molding or plastic machine. It's much less. Talking about prices, I would be happy. You can reach out all the time to me, but it's much less, for instance, than injection molding. So it's less than you expect, I guess.
So thank you very much for your explanation.
Yeah, thank you for being here. It was a pleasure.
Thank you.